Now we're going to move into Module 2. Module 2 starts to give you the basic building blocks of what went into creating the projections for population growth and employment growth for the state of Georgia as this phase of the statewide water plan. Population growth projections were done using fairly standard demographic methods that we'll explain in a minute. Employment growth forecasts were done by an econometric method based on past data series trends. Both population growth and employment growth was forecast for each of the state water planning districts in the state, and employment growth was also forecast by industry. We then went through a balancing process where we brought the population growth and the employment growth projections sort of to a consensus, where we made sure that we don't think there's going to be huge growth in one region in population but no growth in jobs or any sort of conflicts like that. At the end of this process, we have a nice consistent set of projections for population growth and employment by industry and region for the state of Georgia to use in building the statewide water plan. And now Warren will explain to you a little bit more in depth how the population projections were done.
Jeff has given you the overview, and what I want to do is to explain in a little bit of detail the population projections methodology that we used. The model is referred to as a cohort component model. The cohort is the population broken down by age, sex, and race and ethnic group, and followed over time. So people who were 14 at the time of the 1990 census would be age 24, for example, at the time of the census 2000. So the cohort is that group of people followed over time. The component part of the methodology are the changes that would take place. Simply put, there are three main components of population change. Births. Obviously, the only cohort, the only age group that's affected by births is the newborns, the way that we enter people at the beginning of the age spectrum. So we track birth rates, but in order to track those birth rates, we follow what's happening with the number of women of childbearing age and calculate an age-specific fertility rate. So that's the births component. The second component of change is deaths. Deaths is very much related to age, with the average survival rate decreasing in succeeding years until we get to the very old, and there's no one left in our projections from that cohort. Those two components of change are relatively stable when compared to migration. Migration, the movement of people coming to and leaving an area, is definitely the most dynamic. And add into that migration from other parts of the United States and from abroad. So the migration component, we are calculating net migration, the change in a size of a cohort after you take account of natural changes, birth and death process, that we compute rates of change due to net migration. Those are the three components of population change: births, deaths, and net migration, that we follow for each of those cohorts that I mentioned to begin with. That, in a nutshell, is the demographic model for projecting population. Jeff is now going to explain for you in some greater detail how the methodology for projecting employment change.
To create the projections of employment growth for the state, we used a time series model that projects future employment levels based on past employment levels. This model allows both for trends, in other words, industries that are growing or shrinking, and for the natural business cycle, such as we're experiencing now with recession and growth phases. We use data on over 50 industries in the state, plus our 11 different water planning districts. and made projections for each of those industries in each of those regions. Then we made a series of adjustments to those models that allowed us to, if you will, pool growth rates. What we said was, if one industry is growing strongly in one region of the state, then there's likely to be a similar effect in other regions. Similarly, if a particular region is growing strongly in terms of employment, that's likely to tend to lift most industries in that region. So we use state averages, region averages, and industry averages to adjust the initial forecasts. We then added 2 additional adjustments to the data. One of those was a recession adjustment where because our data ended in 2008, we had to do some manual adjustments for job losses due to the recession that we're currently in. And then finally, we did a balancing between the demographic projections and certain segments of employment. For example, retail, education, healthcare. The jobs in those sectors depend quite closely on population growth in a region. And so we made sure that we had balance and that those grew at roughly the same rate. There was also a final balance adjustment made between the population projections and the employment projections, where we made sure that we had roughly the same growth rates in, for example, again, the retail sector and the population growth for any one of our water planning districts.